Hello everyone, I'm Jia Xu, come from School of Computer Science and Technology, Anhui University. Today I do a presentation on topic of EdgeWorkflowReal, an edge computing-based workflow execution engine for smart systems. Currently, most of smart systems such as smart health, smart grid, and smart logistics are often developed and deployed in the mainstream cloud computing environment. Centralized cloud servers need to process massive data generated by the IoT devices, which bring critical issues such as network congestion, high response latency, limited battery life. In order to solve these problems, the edge computing has started to take center stage. The edge computing can provide computing resources close to the end devices. Compared with cloud computing, edge computing has many advantages, such as low latency, location awareness, extensive geography distribution, massive interconnect node, support real-time application. The business process management are the core components of various smart systems. Its performance directly affects the efficiency of smart systems. Moreover, at the core of the business process management, the workflow technology is attracting increasing people's attention. However, the mainstream workflow engine for smart systems are all cloud-based. As shown in figure, the architecture of EdgeWorkflowReal is divided into three layers: user interface layer, workflow management system layer, and database and computing resource layer. There are three characteristics of EdgeWorkflowReal. Firstly, automatic generation of real edge computing environment according to the user's settings. Secondly, visualized modeling for various workflow structures and binding the workflow task model with real scientific computing tasks. At last, automatic deployed monitoring and evaluation for various workflow tasks in users' customized edge computing environment. Let me show you the usage of demo system. To access our system, the user should register and log first. We can clearly see that the interface may divide into three parts: scientific workflow and edge computing environment setting, result display area, and the detail of the execution result. After the users click the Add button, the page of adding execution plan will be opened. The Add execution plan is divided into 4 steps. The first step is the workflow type selection. The second is the computing task binding. The third is edge computing environment setting. The last step is the optimization algorithm and object setting. In the workflow type selection step, the users need to set the plan name and select the workflow structure. Number of tasks. If the user selects the workflow customization mode, the workflow visualized model will be activated. In the assign computing task step, the relationship between the workflow computing task model and the real scientific computing tasks are built. In the set edge computing environment step, the users need to set the computing resource in edge computing environment for workflow execution. Please note that there is at least one computing resource in each layer. In the set optimization algorithm and objects, the users need to select the offloading strategy, scheduling algorithm, optimization object, and deadline. After the users complete all setting steps, the execution plan is generated. User can click the Run button in the action column to start the simulation process of the plan. When the simulation process is finished, users can click the Real Environment button to start the real environment execution process of the plan. After all computing tasks are executed in real edge computing environments, users can compare the simulation execution result with the real environment execution result. That's all. Thank you for your listening.